the average for everything at the same time, but maybe perhaps by some specific group. So like those of you who teach classes for undergraduates and graduates, maybe you're curious, I don't want just like my average GPA for all my students. I want to split by each group. So then you would first sort by graduate students, sort by undergraduate students, and then get the average of both groups separately. So that's in a sense what we're about to do right now. So maybe you want to calculate something like a wealth score, right? So basically you want to do some type of calculation, but not necessarily on everything, okay? So we need to add some kind of way to choose only what we want to group by. So, and what we just did before was we're going to add this type of mask where we want to see when the data is greater than the mean, okay? So in that case, we added this little bit of logic. So when data is greater than the mean, and when we save that into this thing called mask higher, and then try to print it, we should see when that condition is true, okay? So I think I'm missing one. So if I show just the data, we can kind of relate that back and forth, okay? So for example, on this part, Albania, GDP 1952, this is saying it's false. So basically that's saying that this data point, this was not greater than the mean, okay? So that's our first step. We got to create our groups. I also want to mention that there are many ways of doing this concept of aggregation or grouping by. This is one that is inherent to pandas. Those of you who have taken maybe SQL might know some other methods as well. Okay, so first step is we create our groups, which we have done here. And now let's try doing our aggregation that we're interested in. So I'm going to create a new cell. And let's say that we want to create this index called a wealthy score. And basically, we want to see whether or not, how many times the country has been in groups of lower or higher GDP. So for our sake, we consider that higher is going to be higher than the average, and lower is going to be lower than the average. So we've created two different groups. Okay, so then what should we do? Well, we need to do our aggregation. So this is going to look a little bit different than just going ahead and taking a simple average. Because first, for our wealth score, we're going to use our mask. Oops. And then we're going to do our aggregation. Okay, so if I do aggregate, that's going to be a method that I can use. And then I can pass on what kind of function do I want to do. So in my example that I gave you, when I wanted to get average of different groups of students, I can pass on the mean. But here I'm interested more in adding up, right? So I want to create a score. So in that case, I'm going to pass the function sum. All right. You also have to tell it, are you trying to pass this function to the rows or the columns? And in this case, we're going to choose access equal to 1. And correct me if I'm wrong, but I believe that's going to be passing it to the columns. Okay. And the next part for our score, and again, this is going to be very context specific. So if you are familiar with this line of work, I am not, this looks like economics, then this type of calculation would be something standardized. You basically would already know that you're going to be adding up your score and then dividing it by how many you have. Okay, but let's take a look at what this is doing. All right, so we're going to add up and then divide by how many we have. So remember, or I'm not sure if this was covered earlier, but if you're trying to add up true and falses, it's going to consider this as zeros and ones. So let's add up false, 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 which would be 0 plus 0 plus 0. Now divided by how many columns do we have? So 1, 2, 3. So 0 plus 0 plus 0 divided by 3, 0. How about the next one? True is a 1 plus 1 plus 1 divided by 3 columns. You should expect a 1. Okay, so that's what we're trying to do. We're trying to get a type of aggregation where we've split by the different groups, and now we want to combine. All right, so let's see what we get. I'm going to first create the wealth score. And this is pretty common, but whenever you're creating some type of object, so like you give an object name an equal, it's just going to create it. We don't have anything in here to actually display it. So typically you can notice that there's a number that pops up on the left. If you get a number that's showing with no error, that's good. That means it ran it. But if you want to actually show it, you can call it back with a print function, for example. All right, so remember, if nothing happens, that's actually not a bad thing. Okay, and just like we expected, we had that false 0 plus 0 plus 0, and then we divided it by 3, we got 0. 1 plus 1 plus 1, divided by 3, we got 1. Okay, so any questions where these numbers came from? This one's interesting. Where did a 0.5 come from? Okay, so it's aggregating, so it's summing across the columns, and then dividing it by how many columns we have. So let's look at Czech Republic. So that's going to be, oh, that one's weird. Hey, that's not what I expected. The 0.5. Yeah, I'm expecting a 0. That's weird. Did anyone catch something I do wrong? Let's see this one. This should be 2 out of 3. Let's check Greece. That's right. I wonder if there's a little shift that's going on, or I missed something. Oh, thank you. So there's more than 3 years. Oh, yeah, you're right. Thank you. Yeah, I just saw that. Yeah, very good. So, yeah, so actually it's working. Yeah, I just didn't notice that there's more than 3 columns. But hopefully that didn't confuse you. Did it still make sense how we came up with these numbers? We're going to be adding up the true and falses as 1s and 0s, then dividing it by how many columns that we have. Okay. So far, so good. Now, we haven't grouped it yet. We've basically done the aggregation. I need to see the results by the groups of interest. And in this case, it looks like we've come up with, let's see, before this line, wealth score not defined. It should be right here. Wealth score equals, that should define it. Let me paste that in there. Okay. Yes, thank you. So it looks like we have a bunch of those groups that we're interested in, right? So some have GDPs that were higher than average for all the years. Some have GDPs that were lower on average for all of those years. So we've already made it some groups of interest, right? Now let's try doing a calculation that's going to take those groups into consideration. So let's try this. So to our data, we're going to group by this group that we've created. Wealth score is now a group. So you can consider 1 as like the highest wealth score group, 0 being the lowest, all right, in this ranking system. And then we're going to group by the wealth score. If I just did this, right, we're going to get some gibberish. Okay. You need to use the print or do something else to it. All right. So I'm still getting gibberish. It's group by, but turns out I can't just group by. I need to do something to it. So in this case, I'm going to see, well, what happens when I do a sum? Okay. So this is a little messy function, but we first have our data. We tell it to group by our wealth score. So in a sense, this is like sorting it into our different groups. And now we're going to do something to it. We're going to add up all of that data. All right. Now try running it with the dot sum. So if you had omitted the dot group by, you would get the total sum of GDP for all of the countries combined in each column, right? So you get the total total GDP for 1952, total GDP for 1957, et cetera. But now it's doing that, but it's grouping it or splitting by those 4 different wealth score groups that we created. All right. So in a sense, you can do something like this, maybe with like your exam scores. You have a raw score, but you want to then convert it by some kind of like classes or some type of other grouping measure that you're interested in. Yes. So that's right here. Basically, this list that we just generated above. So you see that in the group of 1, that includes Austria, Belgium, Denmark, Finland, etc. And that's coming from just calling the original wealth score groups that we created. Okay. Like which values? Oh, well, maybe this might answer that. Once we combine them, we no longer have this information by country anymore. It's now by group, which is the wealth score group. So then if you wanted to see this number next to its country, you would have to combine this this calculation with the original data using like a type of a join. You're joining this new table with this previous table that you have, which is possible, but it might be a little bit better to visualize it in like a plot or something like that. But there's a way to connect this information with the our original countries. That's a good question. So if I only care about looking at, what do you think? If I only care about where it's a 1, how would we do that? We just did it. So let's say I have this wealth score, and I only want it when it's, let's say, above 0.5. So you can do that. You can see, like, if you do have that massive data set with all the countries, you can apply another mask to this wealth score to select just the ones of interest. Maybe that's just for when it's equal to 1 or above 0.5, stuff like that. Okay, time check. How are we doing?
We are, we're supposed to have a break at 10:30, but we're definitely behind. So let's move into plotting.
I think that's good. I think the main aspects of this lesson was covered in terms of like the concept of masking, the concept of aggregating. You can definitely take it a lot further from here. Let's see. Mask hire is not defined. Mask hire is up here. When we did it, when data was greater than the mean. I gotta private message. So if you're wondering who I'm talking to. Okay, so why don't we check out our next part, which is going to be on plotting. Okay, so similar to what I was mentioning here, there's a lot of different ways of getting what you need. For example, aggregation. This is the one that's inherent to pandas. I don't use it, honestly. There's way easier ones to do. But when you're teaching the concepts, it's definitely the one to go to because the more easy to use, so to speak, they actually are referring to the exact code in a term in what's called a wrapper. So you're using a simplified code that's going to be doing the exact same thing in the background. So that's why it's important to see how exactly these things are working. So very similarly, why don't we start looking at data visualization or plotting? And again, the code that we're about to explore, it's going to look maybe a little chunkier than what you might find in examples online, because this is like the backbone code, so to speak. Not really. I mean, there's more behind the scenes. But this is like the most widely used plotting library, and it's called matplotlib. So let's take a look at that. All right. Let me answer the question. So matplotlib, let's import that thing. Import matplotlib. Just as we saw before, and specifically, we're going to be using plots from the .pyplot module. And just as we saw before, it's very convenient to have an alias because I don't want to be typing this long thing every time I'm going to be calling a function. So it's very common to abbreviate this whole thing as PLT. Okay. And let's start with creating simple plots. And it's actually quite nice. So maybe those of you who have used something like Photoshop, you're familiar with the concept of layers in your images. So you start with like a base layer, and you can add more additional layers on top. And then the final image is really like a flattened version of all these different 3D layers that you're adding on top. So that's kind of what we're going to be doing. So we need to first have some data. So why don't we create some basic data? Let's say this was some kind of like time series data. So I'm going to have some time points. Notice I'm creating a list, 0, 1, 2, 3. And I'm going to have some data. It looks like this is representing kilometers. So time in hours, and this is some kind of position. Maybe it's like a physics thing. And it looks like at time 0, it went 0 kilometers. At time 1, it went 100. Time 3, but index to 200, and then 300. So starting with some basic data. Okay. So let's start building a plot. And when you build a plot, you need to have some kind of a like background or a base of the plot. And to specify that, we're going to use the plot function. So not that, it's a bit more intuitive. So coming from the plot module, we're going to be using the plot function. And this is going to be position versus time. So we'll have time in the x-axis. So the first position, it's assuming is x. And then we'll have position and y. All right. So just this code alone is going to tell Python, like, what's my background map going to look like? And just from this line alone, it knows it's going to have a time in x and position and y. All right. And just like any good graph, you should have some labels. So let's add some labels to our x label. And you'll notice that it's relatively intuitive. Let's give it a label of like time and hours. Oops. And then to our y, oops, not plot, PLT. Oh, if you get a mess up, it could be that. I do that a lot in matplotlib. I'm thinking plot, so I'm typing plot, but really the alias is PLT. And then let's add a Y label. And let's call it position in kilometers. Okay. I mean, I think that's done right. I wonder if this will work. Why don't we try it? It's kind of just hanging there. It's not, there we go. Okay. So remember that little number, that's good. That means it is done, successful and running. And what do you notice? We have a nice line plot that it drew, right? So what we're doing now is we're using Jupyter Lab, right? And Jupyter Lab has a lot of convenience. Like for example, we saw earlier that I don't have to put print if it happens to be the last thing in my code for a certain cell. It's just gonna know to print. Same thing with matplotlib. There's actually another thing you're supposed to do in order to show the graph. And it's really good habit to do that. Plot.show. That's going to actually tell matplotlib, by the way, all of this stuff I instructed you to create. So my X and Y axes and with my data and labels, could you please show it? And you can see that we technically didn't need it, but that's just because Jupyter Notebook is convenient. But maybe you're building something more complicated or a script. So it's good practice to throw in this too, right? Plot.show. If you rerun it, it's going to get the same thing. Was everyone able to create a graph? Oh, that thing at the top? There's some options to not show that, but honestly, don't worry about it because when you export this graph for like your publication or like your Word document, you wouldn't copy it, right? So then you can just save the figure directly and it shouldn't have that.
Yeah, and that was the side benefit of plot show is that it made it go away.
Yeah, it made it go away. But just to add to your point, sometimes it does add garbage that you don't want. Luckily, matplotlib, there's so many different ways to customize. So if there's something you don't want, then very likely there's a way to edit it with some additional code. Yeah, but yeah, you're right. That plot.show did have that nice little benefit.
Let's do a quick green checky mark if you have successfully been able to bake this plot before we move on. And then a red X if you have not. And so we could help you out.
Oh, let me scroll up so you can see it.
The code, of course, is also in the learner notes as well.
Thank you.
It ran just the same without plot.show.
Yep. It will. It's going to assume that you want it to show, but just like if you happen to have more stuff after this, it may not give you the results you want. So it is a good thing to add plot.show. Like maybe we want to add this graph to something called the loop. Basically, you want to create multiple graphs, then it needs to know when it's going to show each one. So it's a good habit to put it. I think, I don't know if I can see everyone. I think everyone's okay. Everyone got their graph?
Yeah, no red X's so far.
Okay, great. So I don't know about you, but I'm not going to be putting all my data manually like this. It's gonna be quite tedious and prone to error if you were to do data entry of everything like this, especially have like 10,000 rows. Imagine that. What do you think we can do? What did we just do in the last exercise? Well, we can read our data into pandas. So let's try doing that. So this is assuming that we're using the same data set. Okay, so I'm going to import pandas again. But if you're in the same script, then you technically don't have to, because you probably already did this in the earlier step. but I'm going to add it again just in case. All right, so we're going to be using pandas again. And you probably have already done this. You've read in your data, but just in case, I'm going to add the line again. All right, I'm going to actually just cheat and copy from here. Oh, wait, never mind. We're not using Europe. We're going to use Oceania. Okay, never mind. So we're not using that data. So this is super common. I think this is not the best way to do this, but I'm not gonna lie, I do it all the time. I have a very bad habit of calling any data I'm inputting into pandas as data. Why? Because you just kind of get in the habit of doing that. But it's probably better, as Catherine mentioned, thank you, if you are a bit more specific about what kind of data it is. Otherwise, remember how I already have data above there? I might accidentally override it. And if I'm trying to use it twice in the same code, I'm going to have some weird things going on. So yeah, it's good to actually rename your new data object as something else. And because we're going to be using Oceania data, why not call it something like data Oceania? All right. And in this case, we're going to be importing our data again with that read CSV. And I'm going to be using the Gapminder. For me, my data is in this data folder. So I need to add that to my path. But if yours was just in the same place as your Python notebook that you're running, then you don't need this. Okay. And then I'm going to be adding that Gapminder.csv. Oh, by the way, you can also do this thing. So if I go to data right here, and you find the one that you want, so Oceania is at the bottom, you can right-click the one you want, or if you're on a Mac, that's two-finger click. And then you'll notice you can copy path. That's also helpful too. Right. So instead of typing the whole thing out, you can also copy path. All right, that's a little trick I learned a bit ago. For this example, I'm going to include the index column again. So index call equals country. This is basically like specifying what's your ID. It could be convenient on the analysis that you use, or maybe you don't need to use it. But for this one, I'm going to be using. Okay, so let's see if this ran. Did it work? How do I know? I see that a number appeared and no error, so it's there. But if you would like to see it, you can call it back, either using the print statement, or if you're not going to add any other code, you can just call it back with its name. So Jupyter Notebook understands that this is actually a print that you want, even if you leave it as the last line of code. Okay, and looks like it's working. I thought there are more countries in Oceania, but maybe not for this example. So then let's go ahead and try something fun. Okay, so we're going to do a little bit of data cleaning. If we look at this thing, might not look super pretty to have on a graph. Like, for example, if I want the years in my x-axis, if it says like GDP per cap 1952, GDP per cap 1957, maybe not the most publishable, right? I prefer if it says 1952, 1957, etc., not this GDP per cap. So I want to basically extract the years out of this. Let's try it. So we're going to get the years, and that's going to come from my data, but specifically it's going to come from the columns. So if I put data.columns, I'm now referring just to these names. All right. We can also start to do some type of data cleaning to these names. So basically, I'm trying to get rid of this part. I don't want it. I only want to say 1952, 1957, etc. Okay. If I just see what that looks like. you can see that if I only run data.columns, I have all of this, but it has this junk that I don't want. Okay, so we're gonna replace this with nothing. We're gonna just get rid of it. Replace it with nothing. And if you look at the type of data, this looks like a string. All right, so we're gonna use a string function to replace. I know it's a long code, but if you look at it at one piece of a time, you can see what's going on. And we're gonna replace this with, so whatever you're trying to replace it with comes after the comma. I want to replace it with nothing. That's good. You got it. You're right. Data Oceana, thank you. So I want to replace this part, GDP per cap underscore, with nothing. So for a string, nothing is just quotes, 2 quotes with nothing in it. And then close parentheses. Okay. So if I try saying what that is, oh, look at that. It replaced the first part with nothing. So we cleaned up our data that we're going to use for years. Okay. Now what? Well, I actually want to overwrite this, right? So now that I have the cleaned one, I want to go back to Data Oceana and replace it. All right, so we can do that, make a new box by referring just to the Data Oceana. Columns. Okay, so if I just show it again, it's still the one I don't want. I want to replace all of these with all of these. All right, so I'll set it equal to the years that I just created. But not quite yet. We actually want it to be not, what is this? When I see something in quotes, it's a string, so it's text data. I want it to be a number. So I actually have to convert it to an integer. So we can actually use this method called as type, and then say convert it to an integer. So just to recap, what we're doing is we imported our Data Oceana. We want to make a nice graph. This is going to look kind of messy, right? I'd rather have the years by itself. So we replaced that. So we just have the years, just like this. But the years are not actually numbers. They're strings. So it's like text. How do I convert it to a number, to an integer? I can use dot as type integer. And then I ran it. Nothing happened. No problem. That's what I want, right? Because whenever I create a new object, you won't see anything happen typically unless you call it back. All right. One more thing. Let's try taking a look. Ta-da. Replace the original data, or sorry, original column names with the year. Now what? It's time to make our graph. So we can make our graph using a convenience function of pandas. So what we did up here, sorry if I'm going too much, we did this all manually, right? So we had to tell it, here's my data that's split up into 2 locations. One's in the time object. Here's another one in position. Here's my label. Here's my Y label, and then show it. But if all this information is already in the data frame, I don't have to do all this work. Why? Because we already cleaned it. This is good. I'm good with this. I'm good with this. Make a new cell, and I'm going to do Data Oceana. And maybe I only want to show Australia data. Oh, this is a quiz. So I want to only show Australia data, and I'm trying to index it by a name. Should I use iLock or lock? I'm trying to index it by Australia, so the name of the country. Should I use iLock or lock?
Lock.
Lock, yes, thank you. Okay, good. So that's going to be the name, Australia. We don't, and I want all of the columns, so I don't need to specify anything about the columns. This is just the row Australia. Double check it. Yep. 10039, 1000949. Yep. This is the row of data I want. To this one, I'm going to plot it. Wow. Instant plot. Was everyone able to get a plot?
Can you back up about one line on your screen so I can see that? There you go. Thanks.
Sure. You sure can. So this is just an example of looking at one country. But if I wanted both, I could just get rid of this part. So we'll do that next. Okay, so I'll make a new one. Oh, by the way, you might have already noticed this. I can keep clicking this little plus sign to add a new cell, or over here, it's right here too. I can add a cell below or add a cell above. So I can add a cell below. So same thing as clicking the plus. And let's see what happens if I plot, actually, let's try doing something else first. What if I didn't want this in the X and this in the Y? So you can actually flip it if you use .t, flipping, transposing, right? So that's where it comes from. And then I show both. Okay. So if you don't have any type of subsettings, any type of masking, then it's going to by default show you everything. Okay, so then this is going to now show both. And what's this about? So if someone turns this in as a graph, you're like, this is a nice graph. What is it? How should we specify what it is? We should add. How did we know what this was? We add some labels. Yep, very good. All right, so let's try adding some labels. Maybe I'll add the Y label as GDP per capita. Okay. And maybe you want an X label too. It's optional. It really depends on what's your use case. I'll call it year. There we go. And so forth. All right. I think we have time for one more type of graph. Oh, you mean like add a label on the line? The code, I don't remember off the top of my head, but you can definitely customize this to do a lot of different things. So I've seen where you can add like an equation on each line. You can add confidence intervals, and you can definitely add like the names of something too. You can go as so far as changing something by pixel location. So for example, if you knew like you wanted to add something like literally exactly right here, then you can kind of estimate it by like, this is like maybe like 1,000 pixels to the right and like 2,000 pixels above. So you can really customize and add text wherever you want with this. Thank you. That's a good resource. Plot both on the same graph. Oh, that's the one we just did, yeah. Okay, so as you know, line graphs are not the only type of graph. We can use other things. Let's try another one with the same data. Why don't we try a bar graph? Okay, so if I just did that plot. So just this alone, that's going to give us what we already did. So maybe I want to switch the kind of graph it is into a bar graph. Okay. What happens? There we go. Now we have a bar graph. And maybe you're thinking, this is kind of like hurting my eyes, or you want to change the color. There's a lot of different ways to change the colors and the themes. For example, one is using just by the different themes that are available. So one theme that you might already be accustomed to is one actually not from Python, but from R, is ggplot, has its own like typical sets of colors. So you might want to try a style from there. So in this way, you can customize not just the axes or the data itself, but you can change the theme of the plots. So if I try doing this, you can see that we've changed the entire theme of the graph. Could you change manually like the different sub-axes and the different colors and the bar color? Yes. But you can also just use an entire theme that sets it all at the same time. So it makes it look fancy. Okay. Let's see. What else can I do with this? Well, first of all, any questions so far?
Hey, Ben, how about we go through the notes up until the challenge questions, and then we could post the challenge questions and then go on a break. So,
That sounds good.
and I'm adding some reference links to the notes too for like, the question about other themes. At the top of this plotting section, there's going to be some additional references and for people to look up how to do all the other cool things.
Thank you. Yeah, there's definitely a lot of things that you can change this to. Like there are definitely a lot of other things. And yes, check out those notes to see what other options you have. You can play around with all the different colors. Okay, let's try some more things that we can do. Let's look at a graph of just a line graph again, but maybe you're not interested in the line specifically. So let's get our graph again. And this time I'm going to pull it directly out. Okay, so, oops, sorry, Beta Oceana. Bad habit. All right, so I'm going to recreate this graph that we have above, but I'm going to do it manually so I can play around with it. This one, if you directly use the dot plot, it's going to assume a lot of default things like the color, the pattern that it's giving you, which is a solid line. So maybe I want a little bit more specificity to what I want to do. And I'm going to pull out some information like the years manually and the GDP of Australia. Let's take it out. I'll save it into something called GDP Australia. So only the data that's coming from Australia. All right. And then I'll plot this one by itself. So if I do this, remember plt.plot years GDP Australia. If I did this, like I changed nothing else, then I wasted my time because it's exactly the same. Oh, I misspelled something.
Era Oceana.
Yep, I will mess that up only 20 more times, I promise. So then I spelled it wrong. GDP Australia. There we go. So if I did it just like this, it was literally the same as the one above, right? But the benefit of doing this manually, where you're taking out the data, so the X and the Y, is now I can do something else. Like I can use a comma here to specify an option, right? So maybe I want to change this like this. What is that? Well, let's first see what it does. It made it green, and now everything is a dash dash. Just from this little option here. Okay, so maybe this is going to be reflective of the graph you were trying to show. So other than the default options, you can really, really change things. And yes, you can animate graphs too. That can be very fun. Although that stuff, sometimes it can mess up just because your computer isn't set up to visualize 3D graphics, but it can definitely be very interactive. You can have a nice interactive graph. All right. Let's try making different graphs. So, oh, but any questions about what we just did right now? Okay, so remember this graph right here? Again, what if I want to customize it? Like, I don't like that it has this random word country here. The style's not my style. I wanted this to be another color. So if you're not okay with the default, we can change it. But if you wanted something quick, like you were just kind of perusing the data that you have, you can use these functions that are part of pandas that will make really quick graphs. But again, you don't have to be limited just to that. Let's go ahead and take out the data manually so we can do some stuff. So I'm going to take out the GDP of Australia, which I technically already did, but I'm going to repeat it just so we can see the code together. Australia. And that was by doing data.log. A benefit of doing it this way manually is you can see very clearly when something goes wrong. And if you're working in a team, like a research team or lab, it's helpful when someone writes it in detail, in detail, so that it's easy to follow what's going on. Okay, and this one, we're gonna just take out the data for New Zealand. Okay, and what do I want to do this time? Maybe I want New Zealand to be like this, green and with a dash, but I want Australia to be blue. So let's try that. We're gonna do plot. So X is the years, and then let's show GDP Australia. And let's add an option B minus. And I can now give it a label, and I'll call it Australia. Okay. And then very similarly, I'm going to plot another line, GDP New Zealand, and then I'll give it this option. You can guess already what it's going to look like. Label as New Zealand. Okay. And like I mentioned, I want to play around with more stuff. So maybe I want to move, I want to make sure the legend is like in the upper left. If you leave it at default, the legend may move around somewhere you don't want it to be. I'm going to use the plt.legend and tell it the location, LOC, is going to be in the upper left. Okay. So you'll notice there's so many different options and parameters, and the resources that our team is putting up there can be really helpful to referencing to which one will fit your use case. Okay. Let's add our X label, and that's going to be just a year. And then let's add our Y label, which will be our GDP per capita. And I believe this was all done in US dollars. All right. So let's check it out. Let's see if this is understandable so far, right? Well, let's run it. And we can see how pretty it made it, but is it clear what's going on? So we've split the data manually. So we took out the years earlier, right? So we took out the years earlier, and then we took out the two GDPs separately. So one for Australia that we did up here, and one for New Zealand that we did up here. That let us create two lines separately so that one line can have what? What did the B do? It made it blue, and the G made it green. One dash specified the style as a line. Okay, so we had a blue line and a green line. And you notice over here what happened to the legend? It now looks probably more what we want. We don't have that random word that just says what? Country. Okay, so we really customized the graph and made it look like publishable the way we want it to. Any questions? Are you excited about making graphs now? Yes. Okay, wonderful. Okay, very fun. If you have like this, so we're done with this example for now. We're going to take a short break. Just my 2 cents is if you have like undergraduate or graduate researchers, they really love playing with this stuff. So if you're not into fiddling with like the aesthetics of these graphs, you can really get some excited students to help you create some nice figures. I know that from experience. Otherwise, why don't we take a break, and we'll get back very shortly.